Now, let us see how we can solve part A using method 2. Method 2 is the method of considering perpendicular lines. So part A, the equation is given as x squared plus y squared plus 4x minus 2y equals to 0. And the point of tangency is -1 and 2. This is the point of tangency. That is the point on the circumference of the circle where the tangent meets the curve, meets the circle rather. This is the circle. So from here, what do we do? In method 2, we need to find the coordinates of the center so that we can find the gradient of the radius. If you look at our equation, the coefficient of x squared and y squared are both 1. So we can use this equation in that sense. So I'm going to sketch the circle. Then I assume my point of tangency down here. This is my point of tangency. The coordinates -1 and 2. Then we say this is point A, the point of tangency. Assuming the tangent is coming from point B, this is the tangent. This side is not important. Now we need the coordinates of the center of the circle. This is the radius, which is perpendicular to the tangent. This is the radius. What are the coordinates of the center of the circle? This equation is in the expanded form. So you can compare it to the equation of the circle in the expanded form. And then you get the coordinates of the center by comparing the coefficients. So if you have practice, then you can see that here, the coordinates of the center here are -2 and 1. So what are we going to do? We have 2 points, the center and the point of tangency, which are the end points of the radius. So you can use those 2 points to find the gradient of the radius. So the first thing we are doing here is to find gradient. Yes, to find gradient of the radius. Always know that the radius is a line. So we have 2 points, that is point C, -2 and 1. And then the point of tangency that are called point A, which is -1 and 2. -1 and 2. Let us find the gradient, which is given by m, is changing y, which is y2 minus y1 out of the chain x2 minus x1 equals to this is our x1, y1, x2, y2. We can call these ones x1, y1, x2, y2 to get the same answers. So we substitute y2 is 2 minus y1 is 1 over x2 is -1 minus x1 is -2 equals to, let the calculator simplify for you. 2 minus 1 is 1 over -1 minus -2. I'm also getting 1. So when we divide it here, we shall get 1. So the gradient of the radius is 1. Okay. Now, what do we know? What is the relation between radius and the tangent? The relation is that radius is perpendicular to the tangent, or the tangent is perpendicular to the radius. But we know that the radius is perpendicular to the tangent and vice versa anyway. What do we know about two perpendicular lines? We know that the product of the gradients of any two perpendicular lines is -1. Therefore, we know that it implies that the gradient of the first line, say m1, times the gradient of the second line, m2, equals to -1 on the condition that they are perpendicular lines. So let me call the gradient of the radius m1 and 1. So that we substitute here, m1 is 1 times m2 equals to negative 1. Let us make m2 the subject. Therefore, m2 becomes negative 1. So this negative 1 is the gradient of the tangent. Therefore, gradient of the tangent is negative 1. Since we know the gradient of the tangent and we have the point of tangency, which is also a point on the tangent, we can find the equation of the tangent. Mathematics is very simple. Equation of the tangent. Mathematics is very simple. But I know for you, you don't even have a calculator. Please get a calculator. Now, we know 2 points already. One, we have the point of tangency, negative 1, right? And 2. I've called it A, the point of tangency. And I have the gradient of the tangent into as negative 1. The tangent is a line, so y equals mx plus c, x, y. Substitute. That means 2 equals to m is negative 1 times x is negative 1 plus c. Therefore, c is going to be 1. C is what? C stands for the y-intercept, the point on the y-axis where the tangent cuts the y-axis. So after getting C, then you come and substitute only for M and C in the equation of the line. Therefore, y becomes M is negative 1 x plus C, which is 1. So y becomes negative x plus 1. Thus, this is the equation of the tangent using method